Today we are going to be practicing finding the empirical formula. My very first problem states, find the empirical formula of a compound with 28.03% magnesium, 21.60% silicon, 1.16% hydrogen, and 49.21% oxygen. So the very first thing that I'm going to do is I'm going to go ahead and give each element its own color, and I'm going to establish my columns. So I'm going to make magnesium green, I'm going to make silicon blue, I'm going to make hydrogen pink, and I'm going to make oxygen red, and that will help me distinguish with my numbers and all that kind of stuff, make sure I'm keeping everything straight. So when I am doing a percent to empirical formula, I'm going to go ahead and make sure that everybody has their appropriate percentages first. Okay. So I've taken from my question, I've gone ahead and I've assigned each and made sure everybody has their color. So when I'm dealing with empirical formulas, my very first step is going from percent to mass. And what this means is I'm going to be assuming a 100 gram sample. 28.3% of 100 grams is 28.3 grams. This will be 21.60 grams. This will be 1.16 grams. And this will be 49.21 grams. So that's percent to mass. Now my next step is mass to mole. I'm going to be dividing each of these compounds by their mass from the periodic table. So magnesium's mass on the periodic table is 24.305. So 28.3 divided by 24.305 will give me this long number. Super important whenever you're doing these problems, do not drop numbers at this stage. You're going to want everything that you could possibly have to make sure you get the correct answer. Silicon's mass on the periodic table is 28.086. .6 divided by 28.086 will give me 0.769066439. Hydrogen's mass on the periodic table is 1.008. .16 divided by 1.08 will give me 1.150793651. And then oxygen's mass on the periodic table was 15.999. So 49.21 divided by 15.999, that will give me 3.075817239. Okay, so we have done percent to mass. We have done mass to mole. Now we are going to find the smallest value that was created from here, which is going to be that of silicon. And I'm going to divide everything by small, which will be my blue number. So everything gets 0.769066439 as my divisor, as my denominator, I should say. Okay. Any number divided by itself will give me 1, so I'm just going to go ahead and establish that. And then I'm going to go ahead and divide. Now, because I have a fancy calculator, I can steal the original number and make sure that I don't accidentally mistype whenever I'm writing it out. If you do not have a fancy calculator, you're going to need to go ahead and plug everything in yourself. Just be super careful. Whenever you're typing it in, making sure that you're grabbing the correct numbers. Okay, so now I have everything out. I can go ahead and look at it. Now, this is the portion where you can decide to round things. So 1.514 is going to be close enough to 1.5. 1.49 is going to be close enough to 1.5. And then 3.999 is going to be close enough to 4. So I've done percent to mass, mass to mole, I've divided by small. Now I need to multiply until whole. So 1.5 is both of my not whole numbers, which is nice. That makes it easy for me to see what I need to do. I need to multiply 1.5 by something, and I'm going to multiply everybody by that exact same thing to get me a whole number. 1.5 times 2 will allow me to do that. So I'm going to multiply everything by 2. And okay. Now that I have all these as whole numbers, I can go ahead and establish them in the actual equation. So I have, you generally go in order. Whatever order I presented the percentages in, that's the order of your actual compounds. So we have magnesium, my subscript is going to be 3. We have silicon, my subscript is going to be 2. We have hydrogen, my subscript is going to be 3. And then oxygen, my subscript is going to be 8. Next, I'm going to be finding the empirical formula for a compound with 59.9% carbon. .06% hydrogen. That's too close. I'm going to have issues. Go ahead and erase that hydrogen. I'll move it over. 0.06%. And then 32.0% oxygen. Okay. I have my percents. Now I'm going to go from percent to mass. So 59.9% will turn into 59.9 grams. 8.06% will turn into 8.06 grams. 32.0% will turn into 32.0 grams. Now I will go from mass to mole. So I'm going to be dividing carbon's mass by 12.011. So 59.9 divided by 12.011 gives me 4.987095163. Hydrogen, I am going to be dividing by 1.008. And that will give me 7.9960311746. And oxygen I will be dividing by 15.999. So 32 divided by 15.999. That gives me 2.000125008. Okay, so I've done percent to mass, mass to mole. Now I need to go ahead and divide by small. My smallest number was from oxygen, so I'm going to divide all of my things by oxygen mole, so 2.000125,008, 2.000125,008. Okay, this is going to obviously equal 1 for oxygen, and then I just need to figure out for everybody else. So again, fancy calculator means less work for me. I'm going to get the number 2.493391735. And 3.997765,997. Okay. I'm going to go ahead and round those. So 2.49339, whatever, is going to be close enough to 2.5. 3.9977 is going to be close enough to 4, and 1 is obviously already a whole number. So I do not have whole numbers here. I need to go ahead and multiply to a whole. My only non-whole number here is 2.5. 0.5 times 2 will give me a whole number, so I'm going to multiply everything by 2. And then I'll establish my actual equation. So again, in order, I'm going to go ahead and say carbon has a subscript of 5, hydrogen has a subscript of 8, and oxygen is going to have a subscript of 2. And that will be it for that problem. And I can go ahead and move to this very last problem here. So this very last problem says find the empirical formula for a compound with 24.8% carbon, 2.0% oxygen, and 73.1% chlorine. So first step, percent to mass, 24.8% will turn into 24.8 grams, 2.0% will turn into 2.0 grams, 73.1% will turn into 73.1 grams. We've done percent to mass, then we need to do mass to moles. So we're going to go ahead and divide carbon by carbon's mass on the periodic table, which was 12.011. Oops. Okay, that will give me the number 2.064773957. Again, this is not the step where we get to decide if we get to round. Hydrogen, we're going to be dividing by 1.008. So 2 divided by 1.08. That gets me the number 1.984126984. Chlorine, we are going to be dividing by 35.453. Okay. When I'm looking at these, I can see that my smallest number is going to be that of hydrogen, so I'm going to divide all of my numbers by hydrogens, which was 1.984126984. This is obviously going to be 1 for this. And then I can go ahead and divide this by that. That will give me, oops, wrong color, 1.04060. Nope, not zero after that. Okay, 0646074. And 1.039189914. Okay. So that is going to be close enough to 1 for me. And so is oxygens, which means that my empirical formula for this compound is going to be C1H1Cl. Continuing on, we are going to do the empirical formula for a compound that contains 67.9% carbon, 5 point, oops. It's supposed to be hydrogen. Okay, 5.70% hydrogen, and then with nitrogen, we're going to do 26.4%. Okay, first part is percent to mass, so 67.9% turns into 67.9 grams. 5.70% turns into 5.70 grams. Nitrogen, 26.4% turns into 26.4 grams. Percent to mass, now we need to do mass to mole, so we're going to go ahead and divide carbon by carbon's mass on the periodic table, which was 12.011. So 67.9 divided by 12.011 gives me 5.65315127.8. .70 will be divided by 1.008. And nitrogen will be divided by 14.007. Okay, so 26.4 divided by 14.007 gives me 1.88477719. I did percent to mass, mass to mole. Now I need to divide by small, which is going to be my number from nitrogen. So I'll divide all of the numbers by 1.88477719. This is obviously going to be 1. And so that 5.653, that's going to give me 2.999382195, which is going to be close enough to 3. And we got 3.000236742, which is going to be close enough to 3. Since all of these numbers are already whole numbers, I don't need to multiply them by anything, and I can go ahead and just establish the formula. So we're going to have C3H3N, no subscript because we don't write ones. And that's it.